Climate change is actually real. We can see it every day, we hear about it every day in the news. There's new forest fires everywhere, there's droughts, there's flooding, temperature increases in the ocean, and we need to do something now. We can't keep relying on fossil fuels, we need to find alternative energy sources, and one of the main energy sources that we've got is the ocean. We've got development of wave and tide, and there's so much potential in the ocean. But at the moment, the hurdle for these developers is very difficult to get consent for their devices to go into the water, because there's this idea that there's going to be a big impact on animals. But to date, all the research that's been going on, there has not been any negative impact, especially from singular devices. We can't keep increasing with our fossil fuels, so we need to act now, and we need to start developing different forms of renewable energy.
What we want to do is get the best picture of what the risk really is by these renewable energy devices, because a lot of the previous work has been very precautionary, putting a limitation on these developers and the speed in which we can develop the tidal energy industry and tackle climate change. And that's what we need to do. We need to keep helping the renewable energy industry to grow, because it is the solution that we need to stop the damage that's going to happen from climate change. Also the other contributions they make, such as oil spills or seismic exploration and the damage it does to cetaceans and other marine life. We use many different tactics to kind of investigate various potential stresses to the marine environment, like the changes to the hydrodynamics, the changes to the benthic communities, the microorganisms. And then you're moving up through these trophic levels up to the kind of work that I focus on, which is looking at the potential effects to larger animals like seals, and the potential for these animals to, say, collide with or be affected in their distributions by these renewable energy devices. Throughout my time here at Queen's University, the main bulk of my work has been developing this new approach to collision risk modelling, where I've been simulating the 3D environment and the movement of a 3D shape of an animal like a seal, and the 3D shape and the movement of a tidal energy device. And then over thousands upon thousands of simulations, I can then calculate the probability of animals colliding with that device to investigate how animals are behaving around tidal devices. But the trend I've seen, that each time we assess a device, each result coming out is that the risk being posed to these is less than we previously thought. Right now we still have not seen a single collision, we've not seen no clear evidence of any detrimental effect. And what we therefore need is more devices in the water and more monitoring happening on those devices to try and truly understand the risks that are posed. Here at Queen's, we're trying to use as many different sources as we can, and we're using new types of video cameras, new types of different visual sensors, and moving towards machine learning and artificial intelligence to try and analyse that data and the information coming out of sensors like that. And working with many different departments throughout the university, the engineering department with biological sciences, and then also with computer science department to try and get the best solutions, to get the best data, to get the best answers. Take the best experts from everywhere we can find them and find the best solutions to the problems we have.
So like any design, it starts off on paper. It will be modelled. The engineering side will build a small-scale model, and then they will test that in the tank. So this is our wave tank facility. It's the Coastal Wave Basin. It's an 18 by 16 metre sized area, and we have 24 wave paddles. The main point of this is it's a testing facility for a lot of our wave devices. So there's different types of devices that we can test here in the wave basin. So there's the wave oscillating devices, so basically it's moving up and down in the water with the frequency of the wave. We also have the different types of flap devices. They basically move with the wave motion as well. So the point of the wave tank is that it mimics the coastal environment very nicely, so especially for wave devices. So basically about 0.7 metres in the deepest part, but it actually shallows up. So this facility is used by a number of different people worldwide. The beauty of this wave tank is that it actually can characterise any type of sea state that you possibly want. And we can understand sort of how different wave climates would influence the power takeoff and how it influences the movement of these devices and how much energy they can extract. We've also got the tidal test site out in the loch here that we do a lot of work with developers, and the whole point of what we're doing is to actually understand the environmental interactions of these devices.
Seals, whales and dolphins are very highly intelligent and highly mobile animals. We know that they have very highly evolved sensory systems. However, there are unfortunately lots of examples of interactions between human activities and marine mammals. Take fisheries bycatch, for example, where hundreds of dolphins and porpoises get caught in fisheries nets every year. And some species are actually known to be quite curious and can be attracted to novel stimuli. Now, we'd like to think that tidal turbines being fixed to one place, the fact that they make noise, we know that they're audible to most marine mammal species. The evidence we've collected to date with tagging studies with seals, acoustic monitoring for porpoises and dolphins is pretty positive. One study that we've done recently used a 3D array of hydrophones, which is underwater microphones, around a turbine to track porpoises, so we can actually reconstruct tracks in fine scale very close to the turbine. Over a year of monitoring, very intensive monitoring, 24 hours a day, 7 days a week, we found there wasn't a single example or incidence of a porpoise actually moving through the rotor swept area when the turbine was operating, which is really good news. And we actually found evidence that porpoises actually spent a lot more time around the base of the device, but it could be that these porpoises were exploiting fish that were gathered around the structure. Other studies have shown that there have been clear increases in fish biomass around structures. And we've also seen this with some of our seal tagging studies around offshore wind farms. The next challenge for us is transferring these results to other places, other species, other studies, other technology types, and crucially at bigger scales. Also designing mitigation approaches as a backup should we ever find that there's an issue. For example, automated systems that will detect animals coming close to structures and then play sounds to divert them away from the risk area. I think that the research that we're carrying out in this area is really important. Global climate change is a massive threat to all marine ecosystems, and we're already seeing some big effects for some marine mammal species. For example, the increases in the levels of algal biotoxin in food chains, and also we're seeing things like the increased incidence of infectious diseases. So therefore, a future with 100% of energy from renewable sources has to be our goal.
We're the technology provider, so we've developed a hydrokinetic turbine that operates in free-flowing water streams, so it's ideal to the site here at Strangford.
This model, it's got a very unique design where we use a bluff body to accelerate the flow. And the turbines in are designed specifically for that accelerated flow. It's a very nice location to test a turbine. One of the nicest things we see here is the clarity of the water actually, because we've tested in other places and you can't see the turbine, but the water up here is so clear, it's great. Really good for studying wildlife as well, obviously, because you can see how they behave around the turbine. And probably one of the biggest things, it's great to work with the guys in Queen's, and the marine ops guys. Everybody really is really helpful here.
Clean energy is the only way forward for the future. So for us, these types of projects are critical to just demonstrate the device, demonstrate that it has very low to no impact on wildlife, and that they're viable solutions that can and should be rolled out as soon as possible to make the transition over to clean energy.
Tidal power has actually been around for a very long time. In fact, where I'm standing now is Strangford Loch. They've had a tidal mill already back in the 1800s, and it's just astounding that we haven't got more of it at the moment. There has been a perception that these big tidal devices are going to, create seal smoothies or fish smoothies. There is absolutely no evidence to suggest that they actually have any detrimental impact. We know that we've got the technology, we know the destruction or the devastation that's been caused by the oil and gas industry, the increases of CO2 in the environment, the changes in temperature, climate change. We can do it, we've got the technology, we need to use it now.